Let's dive right into today's explainer, where we're tackling the unseen forces that literally shape our universe. We're zeroing in on something absolutely magnificent, the beautiful barred Seyfert 1 galaxy, NGC 1097. We're going to unpack some incredibly detailed data today and figure out exactly what drives the massive engines at the heart of galaxies just like this one.
So here's our roadmap. We'll start with the wonders of NGC 1097, then move on to galactic dynamics, hit the magnetic puzzle, shift gears to the electric universe model, and finally wrap up with circuitry in the cosmos.
All right, Part 1, The Wonders of NGC 1097, a true cosmic masterpiece.
Just think about the sheer scale of NGC 1097, or as it's also known, ARP 77. We're talking about a massive structure, located some 45 million light-years away in the Fornax constellation. It's a Seyfert 1 galaxy, which basically means it has a highly active center. You see that prominent, gorgeous structure right near the middle? That's a massive, 2 kiloparsec-wide starburst ring, and it completely surrounds a feeding active nucleus. The velocity fields map out all the complex, swirling motions of gas and dust spinning around that core. And the big million-dollar question astronomers have been obsessing over is this: how does all that material actually travel from the outer, freezing reaches of the galaxy all the way down into that central feeding engine?
That brings us to Section 2, Gravity and Galactic Dynamics. The pull of gravity.
So the mainstream baseline is that gravity pulls matter along a 7.9 kiloparsec galactic bar right toward this central active engine. In this conventional view, sitting at the very heart of the galaxy is a supermassive black hole. It's fed by this wildly spinning accretion disk of superheated material, and it's often wrapped in a dusty molecular torus. You can kind of picture it like a giant cosmic donut. According to the standard model, gravity is the ultimate director running the whole show.
Mainstream astronomers interpret the structural signatures we see as gas being shocked and redirected through what are called Lindblad resonances, eventually forming that dense ring. Basically, as the gas flows along the massive galactic bar, it hits these specific orbits where the gravitational pull causes it to suddenly lose its angular momentum. The gas essentially slams into itself. It's literally like a massive cosmic traffic jam. This creates shocks, and the material drops into a completely new orbit, forming that dense, highly active circumnuclear starburst ring. It's a really elegant gravitational dance.
But that brings us to Section 3, the magnetic puzzle and SOFIA's discoveries.
Here's the catch. If gravity pulls matter in, what controls the final journey to the active nucleus? That's the crucial point here. We need to figure out what force bridges the gap across that central starburst ring. Sure, gravity does a great job explaining how gas piles up into the 2 kiloparsec ring, but something else has to be at play to force the material that final distance down into the black hole. So, researchers turned their attention to magnetic fields. They wanted to measure their orientation and strength to see if, maybe, magnetism was the unseen hand guiding the gas. Well, when astronomers actually looked at the multi-wavelength data from the SOFIA telescope, they were completely blown away. Different wavelengths revealed completely different magnetic field orientations. Check this out. At the 89 micrometer far-infrared wavelength, which traces the cold, dense gas, they found a constant m=0 mode magnetic field right across the ring. But when they looked at the 3.5 and 6.2 centimeter radio wavelengths, which trace the warmer, more diffuse gas, they found a totally different structure. It was a spiral m=2 mode pattern pointing inward toward the center. Oh, and the radio component of the B field points inward on both sides, so you have to ask yourself, how in the world can the exact same physical space hold completely different, highly structured magnetic field orientations just based on the density and temperature of the plasma? It's wild.
So we essentially have two brilliant detectives interpreting the exact same evidence. First, we have the standard astrophysical model. The mainstream magno-hydrodynamic view proposes that gravitational shocks compress the magnetic fields in the dense gas, while a galactic dynamo shears the fields in the diffuse gas to funnel the matter inward. But there is another perspective. The electric universe theory actually predicted these exact kinds of distinct, multi-layered magnetic field alignments long before the SOFIA data was even collected, suggesting that coaxial counter-rotating plasma sheaths generate specific magnetic field orientations at different layers.
Let's shift our lens impartially over to Section 4, the electric universe model, a plasma viewpoint. Electric universe theorists argue that cosmic structures are actually governed by massive, field-aligned electrical currents called Birkeland currents. In this model, space isn't just some electrically neutral void totally dominated by gravity. Instead, the universe is overwhelmingly made of plasma, and plasma is highly conductive. When cosmic electric currents flow through this plasma, they generate magnetic fields that wrap around the current. This squeezes it into incredibly stable, spiraling structures, filaments that can span entire galaxies, dragging both ionized and unionized matter along their path.
And as the literature states, the current stream is free to move and distribute itself so as to minimize the internally stored potential energy. This implies that cosmic plasmas naturally form complex coaxial sheaths to achieve a minimum energy state. And you know what? That directly matches the layered magnetic field seen in the SOFIA data. Think about it like a giant cosmic wire. To minimize energy, the plasma segregates itself. Different layers of the current flow in completely different directions carrying different molecular species. Heavy molecules in one layer, lighter ones in another. This perfectly explains why observations at 89 micrometers show a completely different magnetic orientation than the radio observations at 3.5 centimeters. So from this viewpoint, we aren't just seeing gas colliding. We're literally seeing the cross-section of an immense, self-organizing electrical cable feeding the galaxy.
Let's bring it all together in Section 5, Circuitry in the Cosmos. Fractal toroids.
To see how this circuitry physically manifests in deep space, we just have to look at the Hourglass Planetary Nebula, or M29. You can clearly see concentric cylinders of matter squeezing down in what's known as a filamentary Z-pinch, which increases current density and brightness. From the electrical perspective, this is definitely not just gas randomly exploding outward in a chaotic way. Those distinct, glowing concentric cylinders are the literal sheaths of a Birkeland current. As the current pinches at the center, the current density spikes massively, creating that incredibly bright central star. It's a highly ordered electromagnetic structure holding its shape over vast, vast distances. So, if we apply this electrical viewpoint, the galaxy isn't some random, chaotic void. It's a highly structured, dynamically held together system of fractal toroidal currents. First, a primary fractal torus ring current forms in the galaxy. Then, it breaks down into smaller perpendicular ring currents. Finally, these highly organized currents hold the galactic matter in incredibly structured, coherent movements. This fractal architecture means the motions of the gas and dust aren't just turbulent or thermal, they are purposeful, directed by an overarching electromagnetic grid acting as the scaffolding for the entire galaxy.
As we wrap up today's explainer, I want to leave you with this ultimate question. What roles do electricity and magnetism truly play in the galaxy? When you look at the brilliant rings of ARP-77, located those 45 million light-years away, are you witnessing the aftermath of gravitational collisions slowly draining matter into a supermassive sinkhole? Or are you looking straight down the barrel of a multi-layered cosmic circuit, lighting up the darkness through the sheer power of electricity? The data from telescopes like SOFIA just keeps challenging our understanding, and it forces us to keep an open mind. Keep learning, keep questioning, and I'll catch you in the next explainer.